Let's discuss how to wire an LED. You don't need anything fancy like the Hello World circuit board to wire an LED. You can do it with just the LED and a battery. Here I have a coin cell battery rated at 3 volts. If I wire the positive and negative leads of the coin cell battery directly to the LED, it comes on and the voltage and current isn't so much that it's going to burn the LED out. Now you wouldn't want to do that in a typical application. Typically what you would like to do is include a resistor to ensure that you maintain the proper current flow through the LED. That way you make sure that the LED is bright enough, but not so bright that it wears out and burns out on you. The two most important factors to consider when wiring your LED are the voltage and current supplied. The LED has what's known as a forward voltage, which is the amount of voltage that is lost or the amount of voltage drop that occurs in order to get the LED to turn on. This LED has a forward voltage of 2.8 volts, and I have a 3 volt battery here. By using the equation V equals IR, or your voltage is equal to your current times the resistance, you can calculate the current supplied. Here I'm using a 47 ohm resistor, and I found that was about right for this LED and for this amount of voltage. So let's say you weren't using a battery, but you're using something like a power supply. Here I have an ATX power supply from an old computer that I've refurbished into a desktop power supply. And I can get 3.3 volts off of this, as well as 5 volts and 12 volts. So let's wire it up to this breadboard and power the LED on. Turn the power supply on, and again, just like with that coin cell battery at 3.3 volts and at this amount of forward voltage ratings on this brand of LED, I can wire the LED directly to the power supply without burning it out. You wouldn't want to do this on a typical application. What you want to do is include your resistor into the circuit. So here I can take this resistor. It doesn't matter if you put it before or after the LED, it's all the same. And include it into the circuit. And now I'm powering the LED, but I know that my current I'm supplying isn't going to be something that's going to burn the LED out. So this would be a proper circuit. But let's say you didn't want the LED to always be on. Well, then you can do something like include a momentary push button. I have one already in the breadboard, and I can just move my circuit over to this push button, and now every time I press the button, the LED turns on and the LED turns off. Now, to stress the importance of having a resistor control your current flow, let's see what happens if I was to do something like wire the LED to the board without the resistor, and at 3.3 volts it's bright, but it's not burning out. What if I went to 5 volts? You can see that the LED flashes bright and then it starts to dim back. When you see that occur, you know you're kind of at the point of failure of your LED. Well, what would happen if I was at 12 volts? there it goes. This LED's just burned out. 12 volts with no resistor in the circuit completely fried that LED. And sometimes you can see a discoloration occur to the LED. But so this LED is useless now. If I was to go back to my 3.3 volt supply and plug the LED in, you can see it won't turn on for me anymore. You'll might want to make sure you throw that away and not just back into your box of parts. It can be quite frustrating to be working with an LED and not know it's burned out. So if I grab a new LED and add it into the circuit, it works just fine. So remember, when wiring your LED, make sure that you have the voltage and current right for your LED. Remember that your LED has a forward voltage drop. There's going to be somewhere in the range of 2 to 3 volts depending on the quality and the type of LED that you're working with. Sometimes it can be even more than that. As a good rule of thumb, if you're unsure for these typical dome-topped LEDs, a good safe operating current is anywhere in the 10 to 20 milliamp range. For a 3 volt power supply, 50 ohm resistor is a good target. If you're using something like a 5 volt power supply, you use the equation V equals IR to determine what will get you towards your target current.